A classic problem where a serial dilution is used is in viable count assays. So for those of you that are taking either Phage Safari or any of our microbiology classes, you will be presented with a problem that looks like this. The viable count assay could be used to look at the amount of bacteria that is present in a culture, in which case then you are calculating colony forming units per mil. Or if you're looking at viruses, specifically a class that is known as bacteriophages. Bacteriophages are viruses that infect bacterial cells. You would be calculating plaque forming units per mil. So in performing this assay, typically what is done is your sample of either bacteria or bacteriophage is diluted using a serial dilution and then plated. When counting, typically you want to count either the number of colonies or number of plaques between 30 and 300. Any count that is less than 30 is referred to as too few to count, or TFTC. And any plate that is greater than 300 colonies or plaques are referred to as too numerous to count, or TNTC. So let's look at this problem here. Imagine that I am trying to figure out how many colony forming units per mil are present in this sample. In order to do so, I will make a serial dilution, as you see here in the diagram. So I begin by taking 1 ml and adding it to 9 ml of water. So the dilution that is made, remember dilution from what we saw before is the amount of stock divided by the final or total volume. So the dilution is I've taken 1 ml and I've added it to 9 ml. So my final dilution will be 1 ml plus 9 ml, or 10 ml. So this 1 into 9 is a 10 to the minus 1 dilution, or 0.1. 0.1 of this has now been added to 9.9 ml. So my dilution, and I'll do that over here, my dilution factor is 0.1 of my stock, in which case it's this test tube here, divided by 0.1 plus 9.9. And when I do that, it comes out to 1 over 100, which is the same thing as 0.01, which is the same thing as 10 to the minus 2. So this is a 10 to the minus 2 dilution. 1 ml into 9 ml is the same thing as we saw, so that's a 10 to the minus 1. 0.1 into 9.9, just as we saw here, is 10 to the minus 2, and 10 to the minus 1 and 10 to the minus 1. Now to figure out what the final dilution is, we take our first test tube, and the dilution that you made is the final dilution. So in this case here, the final dilution is 10 to the minus 1. To figure out the final dilution of this test tube, remember we take the final dilution and we multiply it by the dilution that was made. In this case here, that gives us 10 to the minus 1 times 10 to the minus 2, or 10 to the minus 3. To figure out the next one, we multiply our final dilution by the next dilution made. So 10 to the minus 3 times 10 to the minus 1 is 10 to the minus 4. And I can continue doing that as such. Since I only want to count colony forming units or plaque forming units, depending upon if we're looking at bacteria or bacteriophages, I want to count anything that is between 30 and 300. As we can see here, this plate has 250 colonies, therefore it is this dilution that I will use. And to figure out the number of colony forming units or plaque forming units, I use this formula. Number of colonies or plaques divided by the amount plated in mils times the dilution will give you the colony forming units or the plaque forming units. So the number of colonies I have here is 250. I plated 1 mil, so that's going to be divided by 1 mil, times the dilution. Here I use my final dilution. This test tube has a final dilution of 10 to the minus 4. So I will write 10, and then I will switch the sign. So instead of writing minus 4, I'm going to write plus 4. 250 divided by 1 times 10 to the 4th gives me 2.5 times 10 to the 6th. And since we're looking at colony forming units per ml. This is an example of how serial dilutions are used in the lab.